Today, we're going to take a look deep inside our own bodies to uncover something pretty incredible. A kind of hidden intelligence, a secret brain that runs one of our most basic everyday functions. We're talking about the bladder and the surprisingly complex system that's secretly running the whole show.
I mean, have you ever really stopped to think about it? That feeling doesn't just come out of nowhere. It's the result of this super elegant, high-speed communication network between your bladder and your brain. So let's trace those wires and see exactly how it all works.
All right, first up, the body's smart system. And when I say smart, I really mean it. You can forget simple plumbing. What we're looking at here is a piece of high-tech biological engineering, all built around a perfectly coordinated on-off switch.
At its heart, this entire super complex system really boils down to just two fundamental jobs: storing urine safely and then getting rid of it when the time is right. That's it. But oh man, making that happen requires some incredible coordination. Okay, so what's so fascinating is how these two modes are perfect opposites of each other. Check it out. In storage mode, the main bladder muscle, it's called the detrusor, is totally relaxed, so it can fill up like a balloon. At the same time, the outlets are clamped shut. This is your fight-or-flight system, your sympathetic nervous system, keeping everything on lockdown. Then, when it's time for emptying mode, everything flips. The bladder muscle squeezes to push, the outlets relax and open up, and your rest and digest system, the parasympathetic, takes over. It's like a perfectly balanced biological seesaw. So who is in charge of flipping this switch back and forth? Well, that would be the brain. Specifically, this tiny little region in the brainstem called the pontine micturition center. Yeah, let's just call it the PMC. You can think of it as the master control panel. It's getting constant updates from the bladder, and it's the one that makes that final go or no-go decision.
So here's how that whole process plays out in real time. As your bladder starts to fill, these specialized stretch sensors in its wall, they're actually nerves called A delta fibers, send a little status update up the spinal cord. The brain's control center gets the message and notes, okay, fill level is rising. Then, when you consciously decide, yep, now's a good time, the brain gives the green light. That command zips right back down the spinal cord, flipping the system into emptying mode. It's this seamless reflex that we all learn to control when we're toddlers.
But what happens when this beautifully tuned system gets a glitch? That brings us to our next section, when signals go wrong. We're going to get into the science behind what's known as an overactive bladder.
Now, this is probably the most important thing to get straight. Overactive bladder isn't about having a weak bladder. It's really defined by urgency, that sudden, intense feeling that you have to go right now, and it's super hard to ignore. At its core, it's a communication problem. The signals between the bladder and the brain have just gone haywire.
This quote here really gets to the heart of it, the reemergence of reflex micturition. So what does that actually mean? Well, in simple terms, it means the brain's voluntary top-down control gets lost. The bladder basically reverts back to its infant-like programming, where it just automatically empties whenever it feels a little bit full. That learned adult control just isn't there anymore.
Probably the best way to picture it is like this. The nerve fibers in the bladder wall get way too sensitive. They start acting like faulty motion detectors, just blasting "we're full" signals to the brain way too early and way too often. This is the signal static that creates that constant, nagging feeling of urgency. It's just a series of false alarms.
So, if the signaling system is faulty, how in the world do you fix it? Well, that brings us to Section 3, fixing the faulty system. Modern medicine really has two main game plans for trying to get control back over this network.
The goal of any treatment is actually incredibly direct. You either want to stop the bladder muscle from squeezing when it's not supposed to, or you want to help it relax more so it can physically hold more urine before it starts sending out those urgent signals. So either decrease the unwanted activity or increase the capacity. Simple as that.
And here are the two main types of drugs used to do that. On one side, you've got antimuscarinics. Think of these as playing defense. They basically put up a wall and block the contract command from ever reaching the bladder muscle. It's pretty effective, but because the blockers aren't super specific, they can cause side effects elsewhere, like dry mouth. On the other side, you have a newer class called beta-3 agonists. These guys play offense. Instead of blocking a signal, they actively send a relax and expand signal to the bladder. This helps increase its capacity, but it can come with its own set of side effects, like potentially raising blood pressure.
But, these medications don't work for everybody. So what happens when those faulty signals are just too strong, too persistent for these first-line treatments to handle?
Well, for those really persistent cases, there's a much more powerful approach, botulinum toxin. And yep, it's the exact same stuff used for wrinkles. It gets injected right into the bladder wall, and it acts like a circuit breaker. It physically blocks the release of the chemical that tells the muscle to contract. But here's the really wild part. It seems to have a double action effect. It not only stops the unwanted squeezing, but it also seems to quiet down those overactive sensory nerves that were sending all the false alarms to begin with.
So, where does the science go from here? That brings us to our final section, the future of control. Because right now, researchers are looking for even smarter, more targeted ways to get into this complex signaling pathway and fix it.
The future is all about precision. Instead of a shotgun approach, scientists are designing drugs to hit really specific targets. For example, they're looking at things called TRP channels. Those are the very first sensors that detect stretch. The idea is to shut down the false alarm before it even gets sent. Another huge target is P2X3 receptors. These are the sensors that respond to a chemical the bladder lining releases as it fills. If you can block those, you could essentially trick the nervous system into thinking the bladder is less full than it is. And finally, some scientists are looking at the brain itself, hoping to develop smart drugs that can just turn down the sensitivity of the master control panel directly.
And all of this incredible research is pointing towards one ultimate goal: getting perfect, targeted control of the bladder without all the widespread side effects that come from the less precise treatments we have today.
And that kind of leaves us with this one big final thought. We've gone from a simple on-off switch to this amazingly complex web of nerves, receptors, and brain circuits. As science gets better and better at mapping our own internal wiring, the really big question becomes, can we one day achieve complete, personalized control over these fundamental automated systems that we so often just take for granted?